The next unit begins with sequences. And we've got a couple things here. We've got a definition of an infinite sequence here, and we're going to use notation, this bracket here, AN is an ordered list of the numbers that are essentially A1, A2, A3, A4, and so forth, all the way up to AN. The subscript n is what's known as the index variable of the sequence, and the an is the nth term of the sequence. So how we make a sequence, or how we kind of notate the sequence, we're going to do a couple of examples here. Find the 6 terms of a sequence in the following series. We're doing this stuff here. So with problem 1, this one you should probably be able to figure out pretty quickly, but we'll write down each of the 6 ones. A1 is 1 plus negative 1 to the first power. Well, that's just 1 minus 1, which is 0. A2 is going to be 1 plus negative 1 to the second power, which is 1 plus 1, which is 2. A3, we're at negative 1 to the third power instead. That's back to the 1 minus 1, which is 0. A4 is 1 plus negative 1 to the fourth, 1 plus 1 again. That means A5 will be equal to 0, and A6 will be equal to 2. Basically, anytime you have the index variable being an odd number here, you're going to be multiplying, or you're going to be using the exponent of an odd number, which keeps the negative, and thus we get 1 minus 1 is 0. And anytime your index variable is even, you're going to get an even number and a negative number squared. So negative 1 times negative 1 is simply 1. That's where we get 1 plus 1 is 2. So not too bad. The second one, I'll start with A1. It does allow us to do, in both of these cases, n greater than or equal to 1. So A1 equals 1 squared minus 1, which is just 1 minus 1, which is 0. 2 squared minus 1, 2 squared is 4, so that's 3. 3 squared is 9, so that's 8. 4 squared is 16, so that's 15. 5 squared is 25, so this is 24. And finally, 8 to the 6 is 6 squared minus 1. So 36 minus 1 is 35. Now, part of the reason we're going to want to do this is so we can see what sort of patterns form. And I've got a question here from your book. They want us to find an explicit formula for AN, where A1 is 1, and then every subsequent AI value is the previous one plus the given number n. So we're given A1 equals 1. So A2 is going to be equal to A2 minus 1 plus 2. And that's A1 plus 2, which is 1 plus 2, which is 3. A3 is A to the 3 minus 1 plus 3, which is our n. That's A2 plus 3, which is 3 plus 3, but this is also 3 plus 2 plus 1, as before we have that. All right, and this gives us 6. A4, this will give us A3 plus 4, which is going to be 4 plus 3 plus 2 plus 1, which is 10. A5 would be 4 plus 5, which is 5, plus 4 plus 3 plus 2 plus 1, which gives us to 15. And this works its way out as well. But basically, any AN is going to equal n plus n minus 1 plus n minus 2 all the way to plus the 3 plus 2 plus 1 and so forth. So this is kind of a key series that you should have learned in algebra in some way, shape, or form. So if we're just adding up, so essentially it's just 1 plus 2 plus 3 plus 4 all the way up to whatever the n is. This is equivalent to n times n plus 1 over 2. So you notice here, let's do this in a different color here. This is equal to 1 plus 1 plus 1 over 2. Well, that's 2 over 2, which is 1. Well, this is going to equal 2 times 3 over 2, which is just 3. And then this is going to be 3 times 4 over 2, which is 6. And this is going to equal 4 times 5 over 2, which is 10. And this equals 5 times 6 over 2, which is 15. And this is the general format for that. And that's what they're looking for.